Alright, this is 11.2 homework help. I see some of y'all may have some questions on something like number 13, so what I'm going to do is number 14. And we want to determine whether x minus 1/3 minus 1/3 I is a root of p of x, which is equal to 9x squared plus 6x plus 2. Okay. So to do that, I notice that it's a linear term with x having a coefficient of 1, so I can use synthetic division. Okay, so what I do is I said put up in my box. Well, notice this is in parentheses, so it's minus that. So we just leave it as 1/3 minus 1/3 I, because that right there is minus all of that, so we change the sign, which would end up this being all positive. Since it's already in parentheses, we leave it like that. So then, I take my coefficients, 9, 6, and 2, and then I bring down the 9, and then I say, okay, I'm going to do a little scratch work over here. Okay, my scratch work is going to do 9, and I'm going to multiply 9 times 1/3 minus 1/3 I. Well, that just distribute that. That becomes 3 minus 3i. So here I have 3 minus 3i. Well, then 6 plus 3 is 9 minus 3i. Again, I'm going to go back over here and do my little scratch work. I have 9 minus 3i times 1/3 minus 1/3 I. Okay, so then I distribute. And distribute here. Basically, I'm foiling. So 9 times 1/3 is 3. 9 times 1/3 is 3. 1/3 I is 3i. 3i times 1/3 is just minus I. And negative 3i times negative 1/3, so that's plus I squared. But if we remember, I squared is actually negative 1. So then that's 3 minus 1 is 2. And then negative 3i minus I is minus 4i. So this is 2 minus 4i goes here. And I add 2 and 4. That's 4 minus 4i. And we notice that 1/3 minus 1/3 I is not a, or x minus 1/3 minus 1/3 I is not a factor. So that one's very similar to number 13, and that's what happens when you have kind of a binomial, like 1/3 or a conjugate. Okay, this is homework help. Number 24, which is similar to number 23. And what we're trying to do here is we are trying to solve this, or we're trying to factor and then solve. So what I'm going to do is we're going to first test 1, which is the factor x minus 1. So I use synthetic division to do this. I'm going to do 1, 11, 41, 61, and 30. So then that's 1. Okay, so then I do 1 times 1 is 1. 11 plus 1 is 12. 12 times 1 is 12. That's 3 and 53. 1 times 53 is 53. 61 plus 53 is 114, so that's 114. If you look, that's 144, which means that this does not work, because this has to be 0. So now I'm going to try negative 1, because that's x plus 1. Alright, so trying negative 1. Again, I use 1, 11, 41, 61, and 30. So then we do that. We have, bring down the 1, that's negative 1. Right, so then Negative 1 times 1 was negative 1. That gives me 10. 10 times negative 1 is negative 10, which is 31. Then negative 1 times 31 gives me negative 31, so it's 30. Negative 1 times 30 is negative 30, which I notice gives me 0. Alright, so if I notice we got the remainder of 0, so that means that p of x is going to equal x plus 1 times x cubed plus 10x squared plus 31x plus 30. So if I look right there, I still can't factor that. Factoring by grouping is not going to work. So I'm going to have to try another one. And I'm going to go ahead and try negative 2. So if I notice these are all positive, so more than likely the positive one's not going to work. Okay, with those all being positive, positive 2 probably won't work. So this is x plus 2. I'm going to do 1, 10, 31, and 30. Notice I'm using the coefficients from the one from right here. Okay, I've already factored the original, and I found that x plus 1 was 1. And I needed to find another factor, so I'm going to use the factors from, or the coefficients from the new one. So then I bring down 1. That gives me negative 2. That's 8. So 10 minus 2 is 8. 8 times negative 2 is negative 16, which gives me positive 15. So that's negative 30, because negative 2 times 15 is negative 30, and that's 0. So if I look right here, I now know that p of x equals x plus 1 times x plus 2, because I know that this was x plus 1. I found that x plus 2 worked, and then this right here gives me x squared plus 8x plus 15. Well, if I look, I can factor that. That gives me x plus 1 times x plus 2 times x plus 3 times x plus 5. And if I solve that, I get x equals negative 1, negative 2, negative 3, and negative 5. And that's how you're going to do one like number 23. This was 24. This would be your answer right here.